because the world has changed. The world is changing, the world has changed, and science is changing. Why? Big data, machine learning. We're going to put them together. 20 years ago, not so long ago, beginning of 1990s, we started to speak a lot about big data. Now, since 2010, 2015, the machine learning revolution has arrived. What does this mean for science? What does this mean for research? What does this mean for society? What does this mean for education? It poses many questions. And we need to understand the context, we need to understand what this is, why it's here, and then how can we use it in our scientific research. Because if we don't understand what this means, what is big data, what is machine learning, we won't be able to use it in a responsible way to do science. Otherwise, we'll just be pressing buttons or using our applications, our smartphones, and we don't know what's happening behind. But I'm a mathematician. Mathematicians like to understand how things work, right? We don't take, it says that, the temperature of tomorrow is going to be 25, 35. I want to know why and how do we reach that conclusion. So you understand, in health science is very important. We want to use machine learning and big data to make predictions about health. That's very important. If you make a prediction and the prediction is wrong, it's not good, right? People will not be happy. So, to be able to make your prediction, you have to know the reasons. You have to understand the context, and you have to understand that afterwards we can apply the mathematical methods, because mathematical methods, statistical methods, we know the theory, we know how to explain it when it works, when it doesn't work. But when we put them together, we need to have more understanding. So, there are going to be 4 lectures, 5 lectures. Well, let's some of the lectures will be, I'll do one and a half in one. Anyway, I'm going to start with introduction. That will set all the context of what is big data, what is machine learning, and what can these be done in health science. So this will take me 1.5 hours at least. And we will also speak about the sources of data. We have to know where this data comes from also. It's very important. And you will see that the management of the data is very important as well. We cannot just, we're changing. We cannot just stay with our theorems and our equations and say, okay, we live in a world that's separated an island, but we're not living in an island now. The data is coming everywhere all the time. So we have to know about its management. And then I will resume very quickly because this machine learning techniques for health sciences, I need maybe 60 hours, not 6 hours, 60 hours just to do number 3, but we don't have the time. So I will just point out some very important points that are not necessarily you cannot read. You cannot read these things in textbooks or in papers. A lot of this comes from experience. I'll share. I have a lot of experience because I've been living for many years already. So I've seen a lot of things. I've done a lot of research. I've had a lot of interaction with industry, a lot of interaction with governments, research funding agencies. So I have a lot of experience, and I'll help you. I will transmit. I will communicate some of my experience because the rest, the theory, it's very easy. You go onto the internet today. You go to GitHub and you go here. You go there. All the rest you can find, but the experience you won't find on the internet. Experience, you have to come to me or somebody who's living and has done these things before. So I've been doing a lot of research, and I'm still doing a lot of research with students using machine learning techniques, not necessarily for health science, but for science in general. And then I will show you some applications. The field of health and biomedical sciences is a very rich field because there is a lot of data. Okay. And the question is, how can we exploit this data? And I'll speak about omics data, which is very important today, because we have exceptional machines like genome sequencing machines. We can sequence genomes at incredible speed and incredible volume. And the question is, how can we use these genetic sequences for omic data? What is omics data? It's part of the omics data. I'll speak about the types of omics. It's important to know how these can be used for applications in health and environment. And well, at the end, we won't have much time, so I'll touch about this last time, which is a very important subject. It's called digital twins. The idea is that we can make a virtual replica of somebody else's. The real systems that we deal with are very complex, and we need some simplification and some way of being able to make predictions and make analysis. For example, in health, it's obvious. So if you want to see the effect of a treatment on the propagation of an infectious disease, you cannot say, okay, I will give the vaccination to some people and to other people I will not give. And we'll see some die and some that, okay, that's not very ethical, right? You cannot do that. So what we can do, if we have some digital twin, some replica, some computer model, then the computer model can maybe use us to predict and to plan and to have public health policy, or etc., etc. So there's a lot of importance now. I'll tell you what, for example, Google are doing. Google have become very interested in digital tools for medicine. This is since 1 or 2 years now. It's become a very important subject. Okay, so I'll speak about that. So we'll go all the way from the basics to what's happening today. It's very, very important. This also I will speak also about large language models, ChatGPT. What's happening with large language models? And large language models today are starting to become important for health sciences also. So I will try and give you some kind of understanding of what these large language models, what we call generative models, can do for health science and why we should, in my opinion, be very, very careful when we use them. Okay, so let's go. So, first of all, it's important to have resources, right? So as we say, we can see very far because we stand on the shoulders of giants. Big people came before, lots of very important big people, giants in science. Right? So there's some very good books and very good references. I'll give you all the slides you will have now. Okay. For mathematical biology, for me, still the best is there's a 2-volume classic of J.D. Murray. There are very good books by Brown and many others on mathematical models in epidemiology. And system biology is becoming important. As I said, we have all this omic data, and omic data can help us to understand biology from the systemic point of view. So there's a book by Clip et al. There's a bit pictures here. You can find these references quite easily. These are good basic references on the biology or the mathematical theory and the mathematical biology behind all the research that we do in health sciences. As far as big data and statistical learning, for me, I like this book the most. There are today more and more books on machine learning. Not so many good ones. There are a lot of strange books. This book is an excellent book because it's free. Okay, it's free, but you go to steplearning.com and you can download a free copy. Okay, this is an excellent book. Why do I like it? Because it was written by mathematicians. It's not written by computer science, by machine learning. So it explains machine learning with very, very simple mathematics, with mathematics, sufficient mathematics, so that when you use machine learning algorithms, and you're going to use them all the time, you use them all the time. This is the only book that I know that gives a good mathematical basis without, not very complicated mathematics, but good mathematics and statistics. And you see, they don't call machine learning, they call it statistical learning. Because in fact, why is it statistical learning? Because you're learning from data, and data is, by nature, it's statistical, it's random. There's variations which are due to, otherwise, genetically we would all be the same. Can you imagine? The world would not be a very interesting place. Okay, so that diversity has a random nature. Well, if you're a statistician, you believe. And these books, written by mathematicians, they do not call it machine learning, they call it statistical learning, but it's the same thing. So there are two versions. There's one which uses the R language, and there's a new version which came out just last year, which is completely rewritten using Python. So you can download the R version and the Python version, and all the examples, all the code examples of this book are available for free download. And then there were, but this is already, well, there are books on big data if you want. Okay? Be careful with this one. I'll speak about weapons of math. You know, it's a mass structure. Let's just say, I warn you that these tools, these statistical tools, they can be very dangerous because people tend to believe what the machine says. But the idea of this book is that you need to understand what it says, and then if you understand, then they need to do it. Okay, so I believe my point of view is one needs to understand what's happening. Because otherwise we just puppet, marionettes. We saw puppets the other day. We just marionettes now. It's Google and Facebook and Microsoft. They put in the strings, and we must not be here in the university. We cannot be puppets now. We are here to help the society understand how things work. This is how to understand how. Okay, so that's one thing. I have a lot of stuff on the internet, right? Most of what I do, I try to do it for free. And I really recommend you to go look, but okay, there's too much. Okay, so you need to be guided, I'll try to guide. So I gave last year in Picardie State University, Philippines, I gave 50 or 60 hours of course, and all that course is on this website. It's on the GitHub, all the files of the lectures and all the exercises and all the codes are on the GitHub, but it's better to go to the Google site, and from the Google site you have at least, it tells you what, if you go to the GitHub there's just too much, you just get a lot of files, it's not very useful. But if you go to the site, in the site I have links, and at every link you can see exactly what it corresponds to. So there's a basic course on machine learning and data assimilation. We'll go to speak here about data assimilation. It's something that I've done a lot of research on. And there's also an advanced course on scientific machine learning. Scientific machine learning, for me, is how we use science, in fact mathematics, to understand and to guide the machine learning. So we're not going to use machine learning, and believe what it tells us. We're going to try and put more scientific theory, which means more mathematics, more models, like just as Yusuf been showing you. The question is, can we put the model into the machine learning? Okay, so the AI becomes more intelligent. Why? Because it's using science. And science, we've been doing science for hundreds of years. AI we've been doing for how long? 10 years, 15 years. AI is a very, very, very young science. But science, like we've seen before, Laplace, Poisson, etc. Okay, Maxwell's equations. These are theories that have been developed over hundreds of years, 200, let's say 200 years, the last 200 years. And that scientific knowledge and information, we must try now to put it into the machine, into the AI. So AI has to work together with science, and it's called, it's called scientific machine learning. So it's how we call it CIMPA, which is science plus machine learning, science plus AI. So science is infused, is put into the AI. This way the AI becomes more reliable, more explainable, etc., etc. Okay, we have a possibility. We say not only that the AI give us a result, but that result also includes scientific theory and scientific knowledge. Okay, this sounds very, very vague, but there are very good mathematical techniques to go to do this. I'll show you, towards the end. We don't have time to go into all these things because there's a lot of conflicts, but you should know that if you go onto the advanced course in my CSU of last year, and I'll show you some extracts, you'll see that there's a lot of information, a lot of mathematics that can be used to put the science inside the AI. Okay? And then I've written 2 books which are, I'm sorry to say, but they're good books because they explain, because I'm a very practical person, right? So if you want to know about data assimilation, which is quite specific, there's a book which is very highly cited and Okay, I won't go into that in this course, we won't have time. But if you want, 2 years ago, I published a very big book. It's almost 900 pages now. A very big book with a lot of information of how to use science and AI together. It's called Digital Twins. It's how to go from the models to the data. Data-driven is AI. Model-based is computational science and mathematical models for describing all types of natural processes. So this book has a website. That's the website, and it has a GitHub report. There are hundreds of examples with code in this book, and all of that can be found here. And a lot of what is in this course, and what I'll show you today, what is in this course, in fact, this course is basically, I copy-pasted from the book, and I put it into the course. If you want to, the book is not freely available. I don't have access to the source, otherwise I would try to give it to you. A lot of the book is inside here, okay? So you can find a lot of information directly from books. So that's for the references. One needs to have some resources. Now we have resources. We're going to speak in these lectures about an introduction. I'm going to define big data. I'm going to define machine learning. I'm going to look at the role of big data and machine learning in health sciences, in science in general, but in health science in particular, and show you some current applications and use cases in health science. And then, okay, there's always challenges, and in particular, there's something very important that when we do mathematics or science, we think we don't, we can live in our own world. But in fact, when we start to deal with the real world, with society, with health is society, right? Health is not something that has got nothing to do with fun. One has to consider ethics. Ethics is a branch of philosophy, so we have to do a little bit of philosophy, because we cannot now say, okay, here's my mathematical model, I put it into the AI, and I say that now one should use this public health policy because it's going to improve things, or it's going to be more efficient, or it's going to save lives. It has to be very, very careful about ethics, and I'll show you why. Because ethics, if we do not take care of the ethics, we're going to have models or predictions that are not trustworthy, that cannot be trusted. Okay, so it's a question of trust, and the trust depends on ethical issues. Ethical issues ethics is what is right and what is wrong. What is ethics? Ethics is to say what is right and what is wrong. Of course, right and wrong, these are not, they're not very clear. It's not mathematics. It has to be discussed. It depends on context. But these considerations become as important as the mathematics, as important as the machine learning. Because today there's a lot of machine learning being used. Machine learning relies on data, and it's being used with science or without science to influence choices of society, to influence choices in healthcare, for example, or diseases, or etc., etc. And if we do not take into account the ethics, we're going to, once again, we're going to take a lot of risks, and we cannot avoid now, because of this question of the big data, which is coming into our science. Before, when we did mathematics, we did our theory, and we communicated with other mathematicians, and everybody was happy because in the world of mathematics, everything was fine. But now, the world of mathematics, here in particular, is going towards the society, interacting with society. If we interact with society, we have to take into account a whole lot of new considerations that until now, they were not our concern. But if the mathematics wants to go to the society, and machine learning, AI, goes to the society, right? Okay. AI just by itself, nobody's interested in AI. We're using it every day. It's in our smartphones, it's in Google Translate, it's in this, it's in that. It's in more things than we realize. We're interacting with society. We interact with society. You have to take into consideration what is right and what is wrong, what is good and what is bad. You cannot just say, oh, I have a great theory. I don't care if it's good or it's bad. Now we've got no choice because we're interacting with society. So mathematics lived for many years, some years by itself. Now mathematics not even so. Maxwell and Gauss and all these people, they were doing very, very practical things and interacting with society. So we'll speak about that. We'll speak about big data sources and management, the types of big data, the links with there's a lot of electronic health records, genomic data, medical imaging is a very, very big source of data. Omics data, I'll speak about omics data. Omics data, I think, is the next frontier, very important for scientific research. There are links to system biology, and then you have to start worrying about, because you have a lot of data, how you're going to manage and store. And it's not so simple. You as a PQ, we are not computer scientists, we're not going to do the management and the storage, but you have to understand how it's being done in order to use it. And then what's important for us, whether mathematics and statistics will come in, play a role, is also all kinds of pre-processing and cleaning. Real data is never, it's not well organized. It needs to be cleaned out a lot and organized into tables, into rows, into columns, so that afterwards we can apply statistical and mathematical methods. And then there's the whole question of cybersecurity becomes very important now, because if people are going to start, pirates are going to start changing the data, our models are going to get something completely wrong. Sometimes people, there's a lot of, today in the world, there's a lot of interference. People are interfering in healthcare, in electricity networks. There are many cases in the last few years. I won't mention the countries that are considered to be responsible, but the security of medical data is very, very important. Imagine if medical data is altered or if medical data is diffused. Somebody gets hold of your medical data and tells somebody else, okay? It can change, it can be a very important. So cybersecurity, we are not going to do cybersecurity. Okay, that's cybersecurity expert, but we have to know what it is, so we can take it into account. Something. Today, as I say, the world has changed now, and this is the new world. The new world is to use this data and all this fantastic AI, one needs to understand these things. Then, of course, there's a lot of machine learning techniques. What I will do is I will select 1 or 2 or 3 or 4, very few, that will be, to my mind, the most, which I prefer for some reason, for various reasons, so I'll make some selection because there's a lot. Machine learning is a jungle. AI is a jungle. When you go inside, you realize, there's trees, there's animals, there's everything. So I'll make a quick survey of what is machine learning very quickly, and then I'll make some selections, some spotlights on some important subjects of machine learning that you don't find in the books, okay? There's things that go beyond the books. It has to do with model performance, model validation, model precision, etc., etc. There's a lot of stuff that I can communicate to you which you won't find in the books, which comes from a lot of experience. The rest you can find in the book. The technique, the algorithm. You just go to GitHub, you go to the web, everything's there. But the aspects that concern ethics, reliability, validation, etc., errors, how we measure errors, these you won't find in the books to such a big extent. And then I think there are a lot of use cases. In fact, machine learning has been used a lot today. And I'll try to give you a list and some references for data in disease diagnosis, personalization of treatment, drug discovery, and in many, many, many other domains in which health sciences is where machine learning, or AI, if you like, is becoming more and more present. And then some applications, we'll speak about applications. This will come in the last couple of lectures. Omics and multi-omics data, and I'll speak about scientific machine learning more in detail. This is the subject of the mini project. Physics-informed neural networks and disease-informed neural networks. These are all special cases of scientific machine. So I like this saying of Confucius. I hear and I forget. Okay, so you're listening to me. I know you're going to forget. I see and I remember. Or you can see. I do and I understand. So in the end, it comes down to doing it. Okay. You can read as many things as you like, you can see as many things as you like, but until you do them, you will not understand. So the whole idea here is to do it, of course, and we don't have time in this course to do everything. Take some time, but at least I can give you some of my experience, share my experience about things that have been done. So Okay, and then you can find me all over the web. I'm everywhere. If you look at my name, you see me. So I have an email address, you can send an email. I have a LinkedIn, I have a GitHub, and I have a website here. Also, it's also on GitHub, that's the website that thing. I have other websites also, academic websites. This is the one that I keep up to date. The others are old. I cannot maintain everything. So any news or any new ideas or any new references to do with the subject of static machine learning, you'll find on this website. So anyway, you'll have these references. So you can follow me, and I'd like to share my notes. Okay, so that was the introduction to the introduction. Now I'm going to start the introduction. Yeah. One thing at a time. So this is the introduction. Now here comes the introduction. Where we're going to see what is big data and what is machine learning and why is the world changed? There must be a reason. There is a reason. Okay. Here we go. Okay, so now we can start from the beginning. 11:30. Okay, introduction. So I said we're here. I'm just reporting on definition of big data, machine learning, overview of the role in health sciences, some current applications, and then I'll spend quite a lot of time. I won't finish today. Maybe I will start today and continue tomorrow. Spend a little hour speaking about ethics, because ethics is something that has been overlooked. And I think it's equally important to consider all these things. But you'll see that, in fact, some of the ethics, right and wrong, good and bad, can actually be measured with mathematical and statistical techniques. That's interesting. It shows that it's important. We can quantify to some extent the fact that what we're doing, what we're proposing, the solutions, the methods are ethical or not ethical. This is very interesting. But to do that, you need to understand what ethics is. And nobody speaks about ethics, or we don't speak enough about it. And it's become a very, very important subject. And you'll see what happens. Okay, so first thing. There's a revolution in the 2020s. Okay, maybe it started in 2015 or 2010, but I think it's a revolution in the 2020s. And there are three major reasons. You have to understand these reasons, because why is everybody going crazy about AI? There must be a reason, right? So, I said, we'd like to understand why. If you understand why, then you'll be able to use it in an intelligent way. Okay. The first reason was big data. Okay, big data now. We've got statistical data from all over the place. We have from microscopes, we have from satellites, we have from X-rays, and we have the whole world is just a source of data, right? Satellite data, etc., etc. The first reason for this revolution, what I call the AI revolution or machine learning revolution, is big data. Data has become available. Important. The second thing the second pillar of this revolution is that we have open source machine learning software libraries. So there has been a big movement to distribute and to give the tools to anybody and everybody. So you have this is GitHub, and this is what's called licensing, open licensing. So it's a whole system which enables you to distribute your software with some kind of open licensing. So all this open source revolution has liberated a lot of capacity. And what's great about it, fantastic, the whole world, it's not just for, rich people in America who go to Harvard or go to MIT that can use it. Anybody in any part of the world has access to this. This is great because, in fact, there are brains, there are intelligent people everywhere in the world. And if you give to intelligent people access to these tools and access to the data, then access to the data is also becoming more important. And then the third factor is relatively simple access to cheap computer hardware and to cheap storage. So not only do we have GPUs, in my laptop I have a GPU, right? So I can use my laptop and can do machine learning at incredible speed because it has a GPU inside. GPU came from games, from the gaming world. You need to have very fast computations. And that, together with very big storage capacity, even on the laptop, we have lots of space to store the data. That's the third pillar of the revolution. So these three things together have completely changed the world, and they're changing science. Okay? Availability of big data, libraries and software freely available and shared, a lot of sharing. This has been great. This is really since the beginning of the 2030s. Before everybody wrote his code, it's my code, I don't know what deliberators. You know, it's like when we were children at school, remember we used to write your test or your exam or your essay, you would hide it so nobody else could see. That's finished today because in fact, it's much better to share. By sharing, everybody corrects everybody contributes, and it's bigger than the sum of the parts. And then this hardware, the computer hardware, which is incredible. I mean, when I look at my life now, when I started with and what I have now, it's really amazing. You don't appreciate that. It really has changed the way we contribute. Okay, so number one, I'll go through each factor one after the other, very briefly, one slide on each. So what's big data? So big data, it's important to understand when people say big data, what it means. Big data sometimes, to make it easy to understand, it's defined by the 4V. There's volume, variety, velocity, and veracity. Volume means there's a lot of data. In fact, okay, they say zettabytes. Okay, zettabytes are little. What zettabytes? we have gigabytes. We have 1 gigabyte on one machine. 1,000 gigabytes is a terabyte. 1,000 terabytes is an exabyte, and 1,000 exabytes is a zettabyte. So we're going up. These are very, very, very big quantities. Just illustrate the data created by 2020. This was in 2020, 40 zettabytes of data. It's already 300 times more than 2005. So the volume of data is going up incredibly. 6 billion people have cell phones. I think 6 billion, I think it's even more. It's pretty close to it. World population. If the world population was 6 billion of the 7 billion have cell phones. Okay. This is the data. And every company now has, every university can have in principle terabytes of data. So there is an enormous volume of data. Okay. I'll explain why the volume is important. It becomes important for statistics. Let's say machine learning, in fact, is statistical learning. So the more data you have, in principle, the better your statistical learning can be. And this is very important for statistics. So I like to always go back and say, oh, this is great, what do you solve? But what does it mean to somebody who knows some mathematics? You know some mathematics, we can understand why and how, and for what reason the volume is important. There's a lot of variety of data. Okay, we have, you have tweets, you have video, you have content on Facebook, and you have global data in healthcare. This is in 2011. Okay, I mean, the people who made these slides cannot even make the slides. They cannot even keep up. It's moving so quickly. So there are already exabytes of data. Exabyte is a lot. Exabyte is 1,000 times 1,000. Like if I have, here's a gigabyte. If I put 1 million of these guys next to each other, okay, I have an exabyte. I need 1 million laptops for 1 exabyte. Okay. And in 2011, 150, I think it's way bigger. Okay. The volumes are actually, you cannot even imagine how much data it is today. It has a lot of potential, but has a lot of danger. Velocity, okay. Things are going very fast. But the data is not just in volume, but in its flow, the rate of flow, the rate at which data is arriving. Because streaming data is getting faster and faster and faster. You look at the stock exchange or finance, you look at cars, just the cars. Today I think it's much more than 100 cents. Okay, so, and these things are streaming data, so the data is coming in at an incredible speed as well. And then there's the whole question of veracity. Veracity has to do with truth. Veracity in English means the truth. Can you trust, is this data true? Okay, so there's a lot of question about the uncertainty and the quality of the data. If you have a lot of data, maybe some of your data is of bad quality. Okay, what is the quality of your data? And that raises a lot of other questions about, let's speak about ethics, bias, uncertainty. There are many, many aspects which you cannot just take the data and say, okay, the data is this, so I can make some conclusion. One has to be sure that your data is reliable. You trust your data. So this is a matter of trust. Is it true data? You see, these questions before we never asked them, but now we have to ask. Well, there's a lot of this stuff. It's very many types. It's coming in at an incredible speed. Is it trustworthy? Can we trust the data? And can we trust the methods that we use? So you see, we lived when we were just doing theory, mathematical theory, and theorems, life was easy. But now life is becoming complicated and becoming much more interesting because we're moving into it. And so, the whole danger of this volume is that people say, this was said some years ago, but now it's, there's so much data that we do not need theory anymore. Why are they saying? Because the data knows the theory. Okay. The data, the weather, we try to predict the weather by using mathematical models. We try to predict the evolution of what happens with infectious disease by using mathematical models. But if we have enough data, the data, in fact, it went through the equation. It didn't really go through the equation. The data went through nature, and our mathematical models try to approximate nature, natural processes, anything. So our mathematics are an approximation of nature, but the data itself, it is nature. So people say, and this is what Google and other people are making their money, right? You don't need theory anymore. You can do everything with the data. In other words, everything with artificial intelligence, which is based on data. Orders of data. We'll see. So that's the big risk about all these things, is that with all this variety and all this volume, there's a tendency to say, well, we don't need to learn anything anymore. We don't need to understand. The data is everything. But that's a very, very big danger. As scientists, we cannot accept that. We need to understand and ensure that this data corresponds to satisfy some criteria that we have. Because in science, we know how to check whether our models are good or not good, etc. As far as health data goes, this is a revolution. Diagnostics data, healthcare itself, omics data, we speak about genomics, for example. IoT, that's the Internet of Things, and wearables. Every smartphone, every smartwatch now is generating data, and there's a lot of consumer data. So it's growing. 2025. These are okay. They say it took 20 years to get to 64 zettabytes, and in 5 years, from 2020, we get to triple that amount. So it took 20 years now. In 5 years, we can do 3 times as much, etc. This is just in healthcare. So big data is getting bigger and bigger. You don't realize it, but in fact, it's getting bigger and bigger. So there's a lot of push. And they say that by 2025, they estimate that 35% of all data will be from life sciences and healthcare. So life sciences and healthcare is going to become one of the most data-intensive, data-rich, and the most important subjects for AI and machine learning. You understand? You'll see Google and other people, I say Google because it's representative of what's happening in the world, are getting very excited about healthcare data. Why? Because there's a lot. And they know how to use it. And we have, as we said, our lives are becoming more and more digital. We're becoming digital objects because we can measure anything and everything. And so, well, this is the amount of healthcare data that's generated annually. You can have a look. It's exploding. So before there was a big data revolution. In general, in the coming years, we expect to have a big data revolution in healthcare and health data. Just to show it's very, very important. Factor number 2, open source. So, open source was driven by Google, Apple, Facebook, Amazon, Microsoft. TensorFlow, which is one of the best machine learning AI platforms for big machine learning algorithms. TensorFlow comes from Google. PyTorch, which I like a lot, comes from Facebook. Okay? Then fortunately, they are also open software. These have become open now. They were developed by Google and Facebook, but they become open. Then you have very, very good software developed by academics, by researchers for scikit-learn, for machine learning, and R, which is a very, very general but statistical analysis of it. So it started with the GAPA, and now it's become the default. Everybody has adopted the models of TensorFlow and PyTorch, in other words, everything is really available. So this open source revolution is really the key. Okay, if everybody had to develop their own code, we wouldn't be able to do as much as what we can do today. This is very, very, very important. And the final factor is this part of the speed space. You know, you have CPUs, we have GPUs. Storage the cost of storage has gone down a lot. And then even if you don't have your own computer, you can go through the cloud, you can buy computation capacity, you can buy GPU and CPU time through Amazon Web Services, through Microsoft Azure, so through Google Colab. Google Colab is a very good platform that you can basically your code is going to be running on Google's hardware, and Google Colab up to a certain point is free. Okay? Amazon Web Services, Azure you have to pay for them, so depending on how much data. The prices are going down every day. So even if you don't have very good computation capacity, thanks to the cloud, which is the internet, anybody, anywhere in the world can now have access to reasonable computer. And then along comes machine learning. So I want to show you basically. Let me go back. Okay, so machine learning is a part of artificial intelligence. Machine learning concerns deep learning and intersects with what we call data science. Now there are three types of machine learning, or actually they four. So machine learning, of course, it's a whole subject which requires a couple of 100 hours of lectures, but what is important is to understand the different categories, because different categories of machine learning are used for different contexts and for different. So basically, we subdivide machine learning to make it easy to apprehend into supervised, unsupervised, reinforcement, and today, ChatGPT, it's called self-supervised learning. So before, in the old days, when we used to do regression, everybody knows how to do regression. Remember when you do regression, you have points and you find the best straight line that interpolates the points. This is basically interpolation. It's interpolation and becomes statistical machine learning, because the interpolation is dealing with random data. You took measurements. If the measurements were a straight line, we wouldn't need to do statistics, we wouldn't need to do machine learning, because if the world was a straight line, then we would all be genetically the same. There would be, 10 million of you or 10 billion of you. Okay, but the world is not a straight line. Then you have random variations around the straight line, and you want to find the best fit, the best regression to that straight line. So regression is still one of the basic tools. Regression relies on, it's a part of supervised learning. Why is it supervised learning? Because for every xi, so you have n points I equals 1 to f, for every xi you have yi. Okay? That's supervised learning. We have pairs. We have supervised learning. We have pairs xi, y. Okay? I equals 1 to f. And thanks to the yi, for every xi, we have an associated y. That's what we can call this. These are called, well, there's different ways of calling it. These are called features, these are called responses. So the yi response, and the xi are features. I use this in statistics. We call these covariates, and these response variables, okay, or target, that's what the response will come. So, how can we learn? Because we know the response when we vary it. It's just, we're looking for f, then that's x. But we know that from the data that there is a relationship between every xi and every yi, and the machine learning is going to find f, or the AI. Our idea of AI is looking for the f. Okay? Once you have the f, then we have its power. Because why? We can say, okay, so along comes a new point x, a new feature or a new explanatory variable that we've never seen before. You give me a new variable because I know f. I can find you the y. Otherwise, I can predict. Everybody wants to predict. Or I want to analyze. I want to change the vaccination strategy, and I want to know the SIR, the number of susceptible, infected, and recovered people. I want to, I want to do many, many things. So, I want to understand how a system works, complicated system. If I know the function that maps the inputs, this is what that way, input output. Input, output. Okay? It's just input output maps. And it's called supervised because the y supervises the x. Okay? So we can learn the relationship f. So machine learning is going to learn f. How's it going to learn f? Because we don't know f. Okay? It's going to learn it. How's it going to learn it? It's going to learn it from the data. How's it going to learn it? Well, then we open up a whole lot of stuff. Okay? So I'll speak about some of these things, but there are many, many ways of learning. That's supervised learning. Unsupervised learning is when we don't have a clear input and a clear output, when we have a lot of stuff, different stuff, okay? And we're looking for clusters. We're trying to cluster to put similar things together. You want to the classic image recognition program, they want to recognize the dog, or recognize a cat, or recognize, if it's an autonomous vehicle, it wants to recognize it's in front of me, is there another car, is it a truck, is it a pedestrian, etc. So all these are clustering algorithms. These are called unsupervised learning. Unsupervised learning is also very important for reducing dimension, because in a lot of contexts, natural contexts, we have too many variables, and we want to reduce the number of variables. Unsupervised learning can be used to reduce the variables, to help us to make simpler models which we can explain. Reinforcement learning is something that is more complex. Reinforcement learning was used to, if you know AlphaGo, AlphaGo was written by people from Google, and it's played the game of Go, like chess or Go. Reinforcement learning can be used to play games. You can find strategies for what we want to do. And the new thing that's just arriving now, which we've seen, is called self-supervised learning. So self-supervised learning doesn't need pairs of X and Y. It can learn itself, it supervises itself. So it's automatic learning. This is ready since 2020. Okay, this is what we call generative AI, generative transformers, and these give us what we call large language models. The large language models don't need Xi and Y. They find relationships between Xi and Xi plus 1. Everything is X. You don't have X's and Y's. And large language models are finding relationship between elements of the input. It just needs input and no output. So you understand things are moving. This type of theory is still progressing. It's moving, but it's becoming more and more fast. And there's a lot. I only put a few things here, but there are many, many. Each one of these guys has many, many little guys. There are many little guys. It's becoming a jungle. So I'll help you to try to see some things. Okay. So in summary, so we've seen that there's big data and machine learning. Why is it important in health sciences? In fact, I could put anything. I could put environmental sciences, I could put physical sciences. Basically, you could find a good reason to use them for all of science. They're going to transform the way we approach healthcare because we can analyze very large and very complex data sets. It will enable us, among other things, to improve patient outcomes, to improve public health. One patient, you can do it for one patient, but you can do it for a group of patients, and then if you extrapolate, you can go all the way to improving public health. You can go all the way to a population. It reduces costs and accelerates the research. That's true, right? It's going very, very fast. It's the machine that's doing all the data analysis for you and learning the relationships between the inputs and the outputs. We've got these machines. These are statistical algorithms, which are based on statistical algorithms that are based on statistical theory and mathematical theory that are incredible function finders. They find the function. they find the relations between inputs and outputs. And that's why they reduce costs and they accelerate research. Among the applications, disease diagnosis, what we call personalized medicine. In the United States today, if you have money, even if you don't have money, it depends where you're from. You go to the doctor will take your genome sequence, and as a function of your genome sequence, be able to personalize the treatment they give you. It's becoming very sophisticated. Even the usual, pretty well, not everywhere in the United States. In some parts of the United States, you can have personalized medicine. They don't give you a generic, oh, your head is sore, you're an aspirin. No, they say according to your genome, you have a susceptibility, or you have a sensitivity, or you have this kind of problem. They will give you a treatment which is personalized for even everyday things. A lot of these things has to do with digestion, with cancer, of course, and it goes very, very far. So this is already a reality. So you can have personalized treatment, and now the new thing is drug discovery. Drug discovery is molecular dynamics, it's chemistry. So today, with machine learning, chemistry, we have models for chemistry, scientific models for what's called molecular design. We can simulate the movement of molecules, which is made up of atoms. We can even simulate atoms, movements of atoms, and from movements of atoms we can deduce properties of compounds. The problem with the movement of atoms is that we can do maybe a million atoms, but a million atoms is nothing. Right? A million atoms. If you look at Avogadro's number, what's in 1 million, 10 to the 27, so we're a long way from being able to simulate things. But there are different molecular dynamics methods based on mathematics which enable to drug discovery. But if we have data, the drug discovery can be done much, much more easily. We have a database of genetics, not a genetic database, we have a database of reactions of different people to different drugs, and we can start to look among these things to find the best drugs. This also has to do with, there's a whole lot of work on protein folding, or alpha folds. Google also put together, it's open, open something. I'm making AlphaFold. AlphaFold is a reinforcement learning, machine learning code that learns how proteins fold, and by learning how proteins fold, you can determine the properties of resulting drugs, etc. And then we can go to population health management, epidemic planning, and even epidemic mitigation by using these data. So, there are many types of data, electronic health records. You see, obviously, all of this depends on the fact that you have data. So, it's not very easy in developing countries, but it's becoming more and more. People realize that the data is very important. So, electronic health records are important as much as possible. Sometimes it's done at a clinic level or hospital level, but it's better if it's done at a regional level. So you can get more and more data coming in from different sources and put them together. These are very, very, very valuable records. A lot of genomic data, we speak about that. And of course, a lot of data imaging, sensor data, and even social media data. There's a lot of data. Okay. These data provide valuable insights into health status, treatment effectiveness, disease patterns. You can see there's a lot of data. However, they pose very, very big challenges in terms of data management, integration, cybersecurity, and privacy. Okay? So we need to consider, we're getting more and more data, but this data has a lot of challenges behind it. So I'll speak more about these challenges. We will start today, and I'll continue tomorrow. Okay? So, in terms of machine learning techniques, okay, one uses a lot of things. The best way to get an overview of the most common machine learning output, but I have a lecture on machine learning algorithms, is to go to my course. Okay. What's the use of these? They can help the healthcare professionals to make more accurate predictions, to identify patterns and relationships, and to automate decision making. In the end, and this is one of the the promises and one of the problems is that in the end, these AI or machine learning algorithms can actually make decisions now. Why? Because they can do it very rapidly. And they can take into account a lot of data, a lot of different factors, and make a diagnosis very rapid. Of course, the diagnosis can be checked by physician. One of the most interesting applications of this automatic decision making is, for example, to diagnose certain types of very rare cancer. Sometimes the cancer means there's a few cancerous cells in a large mass around. So, you know, when we want to diagnose cancer, other things we take what's called biopsies. You take a piece of the tissue where you suspect there's some cancer, and you look at that tissue under a microscope, and they color. They use coloring agents to color the different cells, and then a human being has to go and look and see, do I see one cancerous cell or two cancerous cells or something that could be cancerous? Oh. Now, because we had a lot of human beings, a lot of doctors, and we're looking at these, and because we have electronic health records, the electronic health records also contain the biopsies, in other words, the photographs that are taken of the microscopic results, and you have the decision. So we have X inputs and we have outputs. We have the biopsy and we have the diagnosis. In this case, the output can be binary: yes, no, cancer, benign, malignant, benign. The output is not necessarily a number. Very often the output is a category. Rich, poor, high risk of earthquake, medium risk of earthquake, low risk of earthquake. High risk of flood, medium risk, low risk. We don't yet have to say it's going to be 325 millimeters of rain. Tomorrow is much better and much more sense. Intelligent to say there's a high risk, there's a medium risk, there's a low risk. Then you can decide, the public authorities can decide, do I evacuate or do I not evacuate? So very often the YI is a category. Okay, so in this case a category. So you can imagine that an AI code which has been trained on thousands, maybe millions of cancer biopsies that do a reasonably good job of detecting cancer will learn that this image corresponds to yes, and this image corresponds to no. And this has been shown to be very, very, very effective. So they have shown that the machine learning algorithms using neural networks in particular can make very, very, very accurate cancer predictions, and at a very fast rate. But now you can go through thousands of things in a very, very short time. And so they can take decisions. Of course, afterwards we should ask ourselves, should that decision be checked? But at least they can go through a lot of data which doesn't have any information and find the data or the cases where potentially there is something. So decision making is important. Okay. However, I'll speak last. Using machine learning also requires very careful consideration of, can we interpret the models? Can we explain the models? The big problem today is they're saying AI is deciding things about our lives. If the AI model can be explained, if a human can understand, then you can have trust in it. If you cannot trust it, are you going to give your cancer diagnosis decided by a machine? If you don't know what the machine is really doing, of course you don't. No, you wouldn't. I wouldn't. But if you know how the how the algorithm of the AI is working, you understand, that was called explainability or interpretability, then you get to trust. So trust becomes very important. This trust has to do with ethics. So we have to interpret, we have to be able to validate the results. It's also important. How do we validate? So then you need validation is an important part where science comes in. Our scientific models can help us to validate the results. Can we put the scientific models inside the AI so the AI models are validated? That's a good question. And then there's the whole question. So these things need to be examined one by one and very, very carefully, because otherwise, we're going to say, oh, I've got a lot of data. I'll show you a part two. The worst thing is possible. If I've got a lot of data, I'm just going to put it into the machine, and the machine going to give me the answer, and I'm going to say, oh, that, it's going to rain tomorrow, or the disease will stop in 1 week, and so we can stop the quarantine, or etc. etc. There's a risk of flood, there's no risk. It's too easy to rely on the machine or the output of the machine learning. It gives me an error. I say, oh, that I can trust it, but you cannot trust it. One needs to go through this step. These are as important as finding the error. This becomes equally important. You see, before we could just find the error and say, okay, guys, give it to the healthcare people, give it to the civil, the prevention of risk people, or whatever, and say, here's the F, go ahead, you can use it, everything's fine. No, you have to verify all these other things now. So the scientific process now, before it was just to find an F, now it becomes much more complicated. Why? Big data. Big data. And, okay, you can say, well, let's forget about the data, but it's too late. No. Google, Facebook, Amazon, Microsoft, they're forcing us to use it, even if we don't want to. Hospitals, public administrations, they're using the data. They're going to use the data. Why? Because it's like a tsunami. You can do nothing against it. It's a flood. It's coming all over the world. The world has changed. It's changing. And we're going to have to, as scientists, we have more responsibility. We have to be able to tell the public or the society, hey, be careful. This is good because we can interpret, we can validate, it's ethical. Okay, we have to see how to do that. Or otherwise we can say this is no good because it cannot be interpreted, we have to be able to validate, and we have detected unethical things that are against moral, what's good, what's bad. So then, wow, in terms of applications, you can get this and this of applications today, and it depends on what you do. It's not just a single application. I told you that the amount of medical data is exploding, and the more the medical data is saying the world has changed, and whether we like it or not, it's changed, and it's changing, and it's going to change more and more. And so we're going to do disease diagnosis. So machine learning algorithms can analyze, I told you, medical images. They can analyze EHRs, running health records. They can take genomic data, and all these can help professionals to diagnose disease such as cancer, Alzheimer, genetic disorders. All these things can be based on machine learning. Okay? Personalized medicine. Now big data analytics can help doctors provide tailored treatments, which individual treatment. You don't treat every patient the same because it can be not the same. And our reaction to certain types of treatment will not be the same. And now, because we have the data, we can target the treatment to the individual. But you can think of it as targeting the treatment to a population or a subpopulation, or a population in some geographical region, which has certain environmental issues which make it more susceptible or more resistant to something. Okay? So this goes beyond just, when I say personalized, it's personalized for a region, a population. Drug discovery. So this is really the new. This is becoming very important because pharmaceutical manufacturers, the diseases are evolving. I mean, you look at COVID vaccinations, right? Drug discovery becomes very, very, very important today, and machine learning can accelerate the whole process of drug discovery. Why? Because it can predict how effective and how safe a new compound is now. It can identify drug targets, can optimize clinical trial designs, many things. In terms of population health management, we can help organizations to identify populations at risk before something happens. And maybe take some preventative treatment, some vaccination. You can add new fluorides to prevent problems with dental problems, etc. You can monitor disease outbreaks, and you can also evaluate the effectiveness of your interventions and government. So you see, even in mental health now, it's becoming a new thing by analyzing speech patterns, facial expressions, and social media data. One can detect early signs of mental health, such as depression, anxiety. So it's going also to more psychological things, not just physical. Okay? And then there's the whole thing of wearable technology. So more and more people now are wearing devices that are monitoring their health. Okay? Diabetic people, for example, now have machines that don't have to measure their blood sugar all the time. They have a little thing here, which is a little catheter which is inside, and it's continually monitoring your blood level. Okay, so you get a lot of data out of that. And so they can use to monitor all the vital signs, sleep patterns, many things, and all this goes into a model and can tell whether the person is in a safe zone or not in a safe zone as far as personal health is concerned. And then imaging, well, we spoke about imaging before. This automation, the ML, the machine learning, can automate the analysis, such as MRIs and CT scans. Now, MRIs are very huge, they're gigabytes of data. Each MRI scan, very complicated to analyze, and the machine learning algorithm can do it lightning fast, quick, very fast. So you can improve accuracy and reduce the need for manual interpretation, and you can increase the speed. In some MRIs, for example, especially for children, for babies, because you can't move. If you move during the MRI scan, the MRI will not work. So MRI scans have to be fast. Okay, so the faster they are, the better they are, and so you can do a much faster MRI scan and then use the machine learning algorithm to do the necessary interpretation or to correct for the movement. So it becomes very, and then all clinical decision support, healthcare providers get real-time insights into patient health status, treatment option, potential risk, and you can make what's called evidence-based decision making. So you can make decisions based on the evidence, based on the data, and that. The machine learning model has learned from a lot of previous data. So all these things are very important. And then, before going on to the machine learning algorithms themselves, which I'll do tomorrow, I'd like to start saying a few words. I haven't talked about yet. A few words. I'm going to start talking about ethics, because ethics, you understand, we cannot just say, okay, we are mathematicians or we are biologists, we're going to do our thing, and then the world can manage. We're going to give it as a gift, but we're not living in that world anymore. Because we're interacting with the world. Why are we interacting with the world? Because we're using the world's data. The data has changed the way we have to work and the way we have to think. And working and thinking in a data-rich environment, in contact with society, means we have to consider all the aspects of ethics. So ethics is a very big subject. Okay? I'm going to give you a very short introduction, 1 hour introduction to ethics. That will be ethics in terms of thinking. So sorry about that. Usually it works. Sometimes it doesn't. Sometimes it looks like that. It's straight here, let's keep it up showing my mail. Sorry. How is that possible? It's strange, actually. Yeah, very strange. Oh, it's showing up already. Okay, so anyway, let's go quickly through some of these things that are here. Like it's more complicated than 1 second. The trouble is I don't have to wait like this. 1 second. Alright, so I'm going to start with some very general introduction. It reads from one side here. So we need to consider some ethics and responsibility if we're going to use science and machine learning. We're going to use the science and machine learning, but we have to have some definitions. You know, we have to start to understand what the philosophical language is and why it's important. And we'll speak about, in particular, trust and trust as very big necessity to have some definitions of what ethics means for AI, what trustworthiness means in the context of AI. And this is important for us to understand because our models we play with AI. So. And then we'll speak in particular about interpretability and explainability, which become very important in order for the public or the person to whom you're giving the AI model to have trust. Okay? We speak about trust and trustworthiness. Our models are going to have to be either interpretable or explainable. I explain the difference between the two. These are concepts we've decided to be used to define how trustworthy an AI model can be. We don't want black boxes. Nobody's going to trust a black box, especially if your life or your public health or your public safety depends on the outcome of the black box. You have to be, very naive to believe it. And then what becomes very important, I speak a lot about this to my students, I speak to the same. As scientists, it's not enough to do science. You have to communicate the results of your science. And a very important part of our scientific process is also how we communicate the results to the public. Because that's called the narrative. You have to tell a story. A storytelling story. You're not going to invent the story. The story is going to be based on your science. But how do you communicate the fact that this mathematical model or this AI model, which is based on the mathematics, is safe and can be used by somebody? This all has to do with communicating. And it's also how communicating risk and uncertainty. We'll speak about that. So let me just have some very quick sayings. Okay, weapons of math destruction. Mathematics can be destructive. Well, math. Another saying that I like, algorithms, and this is, algorithms are not racist, it's just that your skin is too dark. Okay, in other words, the person who wrote the algorithm says, oh, it's not my fault, it's your fault that you don't like my algorithm. That's not the way to go for science. You cannot do it. And then on the other side, the data people, the data science, machine learning people, they say data is the new oil, it's where the money is, okay? And in data we trust, I don't know if you know, the American banknotes, or the American money is in God we trust. Now it's in data we trust. So be careful, because the data people, Google, Facebook, I say this to be anyway, Microsoft, Apple, I say, you can trust the data. Okay? These are very, very, very dangerous things. You can use it in a destructive way with mathematics. You can say, well, that's not my responsibility. It's your fault that you find that my algorithm is racist and many others. And then you have all this data science. So we need definitions, okay? If we're going to go into this, we're going to need to define this case. So we require clear, shared definitions of a number of important terms and concepts in the context of AI. And we're going to take these from philosophy. The first thing you have, as I say, I'm sorry, but you have to know these things now, because the world, otherwise we're not going to be respected players in the new world. The world has changed, and if you want the scientific community to be respected, we have to be able to speak to them in these terms and understand. So, we have to call that ethics now. So ethics, I told you, it's a subfield, it's a subdomain of philosophy, and it deals with the questions of what is a good action, what is the value of human life, what is justice. Basically, it says what is right and what is wrong. Okay, as you said, it's not absolute. Okay, it's generally viewed as applied ethics and AI ethics, and it has to do with normative issues, things that norm is a law. What is legal and what is illegal, what's right and what's wrong. Okay, so ethics has to do also with the law. And ethical AI can then indicate the development and the use of AI that ensures compliance with ethical laws. In other words, you can ensure that our AI obeys, respects the ethical laws, the laws of ethics. You see, before we had a functionality, it's a functionality. But this functionality is being used for making, life-saving, life-breaking decisions, okay, in some cases. It's doing diagnostics, it's doing prediction. And we have to show it. So one of the major problems, another second important point is bias. So bias is something that has to be avoided at all costs, because bias means that there's a prejudice, that something is favored towards or against a person, an object, or a position. So a bias is something that is an inclination, which is a tendency to create prejudice, to do wrong against a certain, you can take skin color, you can take economic status, rich or poor. Bias, unfortunately, can arise in many, many ways in AI systems. AI systems are known to have bias. They can have biases. It's very, very easy, but I'll get to some of these. And it occurs when the algorithm produces a result that is systematically prejudiced or systematically favors or disfavors due to some bad assumptions in the machine learning process. So you'll see, I'll explain it. It has to do with, there are many ways. When I started studying these things about all bias, I was just wondering that you'll see the sources of bias are very, very, very numerous, and they correspond exactly to parts of the process, what we call the knowledge or the data creation, the knowledge creation process that we get to use, from gathering the data to analyzing the data to designing the model to giving the results. At all of these stages, we have the risk of introducing bias. Okay, so bias, you can say, oh, well, it has to do with philosophers, but not anymore. I told you, our mathematics is now a part of society, and as a part of society, if there is bias, and we have some prejudice, and what you do, we're saying, something bad about somebody because of some reason that's not defendable, we have to take very much care of. And then another very important definition that we need, and I'll speak much more about this, is trust and trustworthiness. So trust is, we'll speak about this. It's the willingness, if you're prepared to assume risk by relying or believing in the actions of another party. So the question of trust becomes very important now. Can you trust the model? And the definition of trustworthy AI, and it's an AI ethical trust, should be lawful, and it should obey the law, it should be ethical, it should obey what is right and what is wrong, and it should be robust. In other words, it cannot be hacked. Nobody can hack it, nobody can change the results without us saying. So these are some very important issues that until now, it didn't concern us very much. So trust and trustworthiness is the first very important. So you see, there's a lot of thinking. I won't go into all the details, but I will leave you these slides so that after you can come back. What I want to show you at some point is, in fact, you can have a checklist. People have taken the time in Europe and in the US to make a check. Okay, what I don't like is might be prejudice because it's made by the US and Europe. I think the whole world should participate in these things. I would like the United Nations to do this, but they're not doing this. They should do that also. So the idea is that there's a lot of these definitions that are kind of complicated. You say, well, how am I going to know whether what I've done is trustworthy, does not have bias, and is ethical? Okay, but I'll give you a checklist afterwards. It's here. You can go back, and at some point in your project, or somebody asks you a question, you can have a checklist and you can verify that each of the points in the checklist have been ticked, right? And another thing that's important is that these issues are not, it's not once and for all. You cannot say, okay, today my machine learning algorithm has checked everything. One has to do this with regulated tools because things change. The world is changing, the data changes, the population changes. So you'll see there's a lot of definitions, but as I say in the end, you can have a checklist which enable you to. There are many, many more key terms. Okay, so there were definitions. There's a group. If you're interested in these aspects, there's this is a group of scientists in environmental science. They're environmental scientists. They're not health scientists. These are people who do a lot with earthquakes, weather prediction, typhoon, tsunamis. These are environmental scientists who've been working a lot. It's just one group that I know of because I participated in a panel with one of the people who work on these issues. And they've done a lot of work, a lot of workshops on this question of ethics for AI. So, what is important is explainability and interpretability. So, these are very subtle things because people can say, well, your AI algorithm is deciding my future, deciding my health, deciding many, many things. I want to understand, but does that mean that the human has to understand every single line of your code or every mathematical formula that you use? Of course, that's quasi impossible because why these AI models are too complex to be interpreted line by line. So there's a whole game between what is required in order that an AI or a machine learning algorithm or the theory behind it can be understood. So this is what's called it's post hoc, which means after the fact. After it's trained, we want to make it understandable, and then interpretable. Interpretable means it needs to be understood by humans without additional explanation. So there are many compromises to be made because you might need to change your algorithm in order to make it explainable or interpretable. Otherwise, if you're going to do something that's just black box, it's going to say, trust me, it's good, why? Because I have a publication. But the publication is one thing, but its use, the actual use of your model in the society is completely another thing. Completely different consequences of a good decision or a bad decision based on it. If they're going to use your AI model, it happened in Italy a few years ago that geologists, or like seismic people in seismic, people who do geology, did not predict that there would be a severe earthquake in Picardie. They decided that the model of the geologists, or that seismologists, was not, said that there would be no earthquake, there was an earthquake. They took the scientists, the researchers like you, they took them to court and they made a trial against them in court. They could have been punished by law. This it becomes serious because you're using models upon which people are going to base their decisions, and these decisions afterwards can be used against you. We're not in our laboratory in our room with our little board doing our little thing. We're going out, we want to help the world, but we have to be accountable to the world also. And that's why we need to have these key terms, and we need to be able to check them, to say, yes, but I checked, this is how I checked, this is how you can explain my model, and if there's an error or there's something, it was due to things that were not under my control, beyond my control. And then you can say, okay, this is my defense. So there are a lot of issues which have to be considered. There's a whole question of trustworthiness. You have to go into that explanation. I'll show you very quickly. Tomorrow we'll go through some of these things. So you should know that trust is relational. It's a relation between the person who trusts and the person who wants to be trusted, and that it's very subjective. It depends on a large number of different. So there are many efforts to try and quantify, which is very, very difficult, but you must understand that some of these things is philosophy, it's social science, and so these things have to be developed. And then I will give you some indication. One of the ways of ensuring trust or trustworthiness is to make your AI either interpretable or explainable as far as possible. Some AI, very deep learning networks, there's no way that a deep learning network is going to be understood by the person who uses it. But you have to explain that it's not necessary to understand every line, but you can trust it. So these things go to trustworthiness. And then it doesn't work. Okay, so it goes on. So I will go very quickly through these things, and what I'll do tomorrow is we will start tomorrow morning, and I'll go quickly to the checklist, and I'll show you what's called the knowledge discovery process, and we'll see where all these issues of interpretability and trust come into the process of what we're going to do. So I'll go to some very, very concrete things, but as I say, we need to understand some basic definitions, and in particular, the trust relation is something that has to do with the relation between a truster and the target, the trustee, okay? And trustworthiness is something that can be evaluated. Why should I trust you? These things we can actually measure, and a lot of these things, in fact, one can develop statistical tools which help to evaluate. But then, of course, I spoke to the thing, I said communication is important. You have to also be able to communicate that your mathematical results or your AI algorithm, which depends on machine learning, which in fact is statistical learning, statistics is mathematics, right? You have to be able to communicate the fact that to the stakeholder, whoever is, to whom you're giving the doctor, the public health people, the national safety people, I don't know, whoever, the government, the ministry, the provincial government, the air pollution people who try to control, etc. You have to be able to communicate to them these elements of trust, these elements of risk, and it's a very important part of the process. And I think that I will also speak a little bit tomorrow about that. And then once we've done all that, then I promise you we're going to do machine learning, and then we're going to do mathematical modeling, how you can use machine learning to combine with scientific, computational science and scientific theory in order to improve the reliability and the trustworthiness of our machine. So that will be for tomorrow. Okay, thank you.